Hello, welcome to Taxonomy Online Mathematics. Let's walk through the few steps that we are going to apply. So first step is to read the problem carefully. Then, if possible, make a sketch of the problem. So whatever quantity is given to you, try to make a sketch of that problem. Then define variables to be used and carefully label the diagram with those variables. So if it's a rectangle, label the length and that of the breadth by defining them. Then write an expression for the quantity that is going to be maximized or minimized. So if in case it is area that has been mentioned, then the quantity will be area, and that will be length times what? Breadth. Then we eliminate some variables. The variables that can be eliminated in case we are dealing with a volume of a cylinder, which is made up of a radius and that of what? A height. It is always good to eliminate one of the variable by replacing one in terms of the other, meaning r in terms of h, so that you have your independent and dependent variable at one side. So now form an equation for this quantity, which will be area or volume, in terms of a single independent variable. As I said, if the volume is made up of r and h, you have to eliminate either the h or the r, so that the independent variable, the h and the r, one will be left, so that you can easily differentiate without using the implicit differentiation. So if the function y is the quantity to be maximized or minimized, find the values of x for which the dy dx is 0. So first thing, after writing the quantity equation, eliminating other variable if possible, you need to find differentiation of that quantity. Then when you differentiate, you set the dy dx to be 0 to find the value of those independent variable. Then text each for which dy dx equals 0 to determine if it is a local maximum or local minimum or neither. So after you find the values of, let's say, a, which is the independent variable, you need to substitute that and text that. You have to put it back into the equation that you have differentiated to see whether you are getting maximum, minimum, or neither. So if the function y is defined in an interval from a to b, or ranging from 0 to infinity, then you have to check the values of the function at the endpoint. So whatever range, don't forget, if you are dealing with measurement of a length, you may not get negative values, right? So it means you are going to cap it from 0 upward. You can't also get a 0 exactly because we are measuring. So 0 will not be inclusive. Numbers greater than 0 up to a certain number, that will be the range. So you pick the end point, the far end point, and you substitute to text which of the values of the independent give you your maximum or minimum. I guess we can remember all the step one by one, because I'll be cleaning it and take a question to text and follow the step if we can be able to solve it accordingly. Let's look at this question. Find the dimension of a rectangle with perimeter 1000 so that the area of the rectangle is maximum. So first of all, we have to define or identify the quantity we are dealing with. Here we have area and perimeter. But which quantity are we trying to find its maximum? That is going to be the area. All right. Next, we are to make a sketch if possible. So in this case, I can make a sketch as this, then have x and y. We have to label them and define the part. So we write let x be the length and y be the breadth by definition. I don't have enough of the space, so we define. Then if that is the case, from this rectangle, putting perimeter as the first quantity, how do we find perimeter of a rectangle? The perimeter of a rectangle is 2 of this plus 2 of this. Meaning, I'll be having 2 of x plus what? Y. But already we know what the perimeter is, which is 1000. So 1000 equals to 2x plus y. I believe we can divide both sides by 2 to have here to be 500 equals to x plus what? Y. So you can see that we are having two variables. We can eliminate one, or we can make one in terms of the other. So here I can make y the subject. So if y is made the subject, x will go here. So you have 500 minus what? X. So here, the last point which we deal with is that if the function is in terms of what? X and y. What do you think will be the values of x? Since we are dealing with the length. You know, you can only get from 0. S can be 0, which can be possible anyway. So we can get 0, we can get 1, up to 500. We cannot get beyond 500 as the range of values of x. Because the moment this is beyond 500, you'll be getting the value of y to be negative, which we know we are dealing with measurement. We can't get a negative value. So our interval is going to be from 0 all the way to 500. Remember, the point says that we should pick the end point. We should pick the end point. So here we can have our interval from 0 to what? 500. All right. Now, this is just the first quantity we have identified. How about the quantity we are asked to maximize? The area of the rectangle is maximum. This is the quantity we are trying to maximize. So we know area, okay, at the maximum, we are going to have the area equals to length times breadth. We know we are defining the quantity. Length times breadth give us the area. But in the beginning, we have the y in terms of this. You see, we have to eliminate one of the variable so that we have only a single independent variable to work with. So here I can rewrite this as x into bracket y. And the y is what? 500 minus what? X. I can expand this to have my area equals to 500x minus what? X squared. So this is what we have for this. This is the quantity we want to maximize. Alright, so if that is the case, we need to find the dy dx. In this case, dA dx of this quantity. That means dA over dx will be equals to 500. We know the x exponent 0 will be 1. Then minus 2x. 2 minus 1. I mean, this minus 1 will give you this. Remember, to find the values at the maximum point, we need to know what the x will be. That is, at dA dx equals to 0, we have our 500 minus 2x also equals to 0. Then if this go here, you having your 2x equals to 500, x will give you 250. Do you get it? So it means that here we are not going to pick this end point again, the beginning point. X could be from 250 up to 500. Do you get it? The interval we are looking for now will be between 250 and 500, so that the value of this could not be 0. Alright, so now that we have this, we can also look for the maximum. So now this is going to be the x value that we are having. Therefore, the interval of x will be, let me just say, the x will be equals to 250 and x will be equals to what? 500. I wanted to state as an interval, but let's pick the endpoint at once. So x will be, we are looking for the maximum, which means there are some numbers between 250 and 500 which will make the area of this rectangle to be maximum. That is the understanding we are trying to put across. right? So now let's put in the values of this and this. You said pick the endpoint. Let's put it into the A and see what will be that maximum value we are referring to. So now what happened? We can now say when x equals to the beginning, your area will be 500 times x, which will be 250 minus 250 or square. So now let's multiply. So 500 times this will give you 125 with 3 zeros minus 250 times 250. That will also give us 625, 2 zeros. If you perform that subtraction, you'll be having 6250. I think, all right. So that will be that. So that is going to be area, so meter square. Then when x also move to the end point 500, what is it going to be? Your area will be 500 times 500 minus 500 square. I believe this will be a value that will be the same as this. So this will give you what? 0. So it means that comparing this and this, which is maximum, 0 is less than this. So I can say that the area, or let's say the maximum area is what? The value is 62,500 meters square and occur at x equals to which value of the x? Okay, 250. Then y equals to, where is the y? Y is 500 minus x, and the x is what? 250. So that will be another 250. Do you get it? So now you can see they have the same dimension. So we can also conclude that the rectangle is a square, because I have both the length and the breadth being the same. So the rectangle that has the maximum value at 62,500 meters square will be a square. I guess the concept building from the introduction steps up to this is grabbed by you. In the next episode, we will pick another question and see if we can follow through. Don't forget to share with somebody, help them subscribe on YouTube, follow on Facebook. Make sure they leave a comment and like the video after watching.